Here the radius is r already. If you know the radius, what's the surface area for sphere?
Something about pi.
4/3 pi.
The volume we know is 4/3 pi r cubed, right?
Yeah.
But what's the surface area?
I don't know, I bet you know.
It's 2 pi r.
2 pi.
Or 2. 2 pi r.
Is it 4?
Times.
Let's look in the back of the
That's the formula.
Oh, 4 pi r.
4 pi r squared. If I give you a cylinder, can you calculate the surface area if I tell you the height of the cylinder and the radius of the cylinder?
I'm allowed to use Google.
Can you calculate? Oh, just something like that,
The base.
Something
right?
about
Yeah.
Can you calculate the surface area plus the top and the bottom?
Right.
I tell you the radius here, tell you how high it is.
Oh, yeah.
Yeah.
Can you?
Yeah.
How about the side area? Can you calculate? How? If you use a scissor, cut it,
Yes.
therefore it will become this. Can you calculate this area?
Yes.
Yeah.
Okay, so this length, if you make it
Times height.
something like that, what's that? That's the circumference, right?
Yeah.
How to calculate circumference if you know radius?
2 pi.
4/3 pi squared.
2 pi
2 pi
Oh,
r.
r,
2
2
pi.
pi r.
Yeah,
Yeah.
that was on the middle the other day.
right?
Yeah.
2 pi r. What's this? This is the 2 pi r. What's this? If you make it
Height.
oh, that's the height. Yes, 2 pi r times height is the side surface, right? So this is the circle. If you know the radius, what's the area of the top?
Is this circle?
Yeah. If you know the radius
Half,
r,
yeah, half of 2 pi r.
it's pi r squared.
Oh my goodness, who didn't say that?
Okay.
Can we imagine how you
Okay,
sing
just
it?
try to let you warm up. Okay? But right here, we only need this one. Therefore, you see, flux equals this. Therefore, our flux, according to this, it equals E times 4 pi r squared for this situation, right?
Yeah.
And now we need Gauss's law. According to Gauss's law, phi equals what? The flux.
Q of the inside over here.
Q inside divided by a constant epsilon 0. Therefore, what do you have if you combine these two together?
We can say
Q over.
Oh.
See,
Q over
this is
4
phi,
pi
this is
epsilon
also
0
phi,
r.
which means this side must equal to this side, right?
Uh-huh.
Therefore, you have E multiply 4 pi r squared must equal to Q inside divided by epsilon 0. Therefore, your E equals what? Can you solve this equation for
Yes.
E?
Q
Yes.
of the inside over.
It's
4
Q
pi.
inside divided by 4 pi epsilon 0 times r squared.
So that too.
And then go back to this picture. How many charges inside this sphere?
Infinity.
Just one point charge Q, right? Therefore, you can remove the inside here and change the capital Q to the given condition small q. Problem solved.
Equals to Q, because that's labeled as Q.
Yep.
If we put big Q, we would be wrong.
Well, if you had big Q.
So you have to match this character. Just try to match this.
Okay.
Little Q.
Any questions? No?
So what's going to happen? We're going to do a sphere here, and then we're going to go home for homework
And get a
do
square.
cube, do a pyramid. I'm like, oh, I get that. That's exactly
That's what's gonna happen.
Yeah, I mean,
Maybe
it's just going to
Dr.
click on
Drew
the no.
will be so kind and he will make up our homeworks, which are a million times better.
Okay. If you don't have questions, I have questions.
So,
Very good.
somebody better come up with a question.
All right. Now we assume this charge is at the center of the sphere, right?
Yeah.
Oh,
If
no.
I take it away from the
See,
center,
I told
will
you to
this
ask
calculation be valid still?
No.
Why not?
the distance
Because-
is different.
Yes.
R is throwing everything.
If this one not at the center, for example, right here, will all the field here the same?
No.
No, here is closer, here is
Yeah.
a little bit far. Therefore, the
Wait a
points on
second.
surface no longer equal. Therefore, you cannot do this.
But if you're saying that was the only charge, because if that was the only charge, wouldn't the whole
We would just
area move
shift.
with it?
Yeah.
So then you would be able to do that.
Okay, you can try. There's one thing here, okay? If you put a tiny charge
Okay,
here,
so you're
which is
keeping
Q
that other charge.
prime,
Yeah. So now it wouldn't. Right.
can you find the field on this surface?
No, not on this one.
No,
Mm-mm.
we have no idea how.
Because R must be constant.
Which means to apply Gauss's law, one condition must be satisfied. Your system must have a symmetry.
Be closed.
Either spherical symmetry, either other kind of symmetry. Without symmetry, you cannot use Gauss's law. Therefore, this law is basically limited. You can only use it to solve some problem with very good symmetry. Otherwise, it's useless. But that's good enough. That's good enough. But if you introduce the calculus combined with Gauss's law, you become very, very powerful. You can calculate a few millions of problems. But right now, we are limited. We can only solve a few of them. Okay, this is one.